Good morning, Philippines. I'm Jean Angelo Trino Tipase, your news anchor for this morning. And you're watching Science Spectrum News Network. We are here to bring you all the fresh and latest news about GMOs, or widely known genetically modified organisms. GMOs are living things like plants or animals that have been changed in the lab using a special process. Scientists take genes from one organism and put them into another one to give it a new traits or new life. Herbert Boyer and Stanley Cohen made the first genetically modified organism in 1973, a bacterium resistant to the antibiotic kanamycin. The first genetically modified animal, a mouse, was created in 1974 by Rudolf J. Nisch, and the first plant was produced in 1983. Also, according to the scientists, bacteria are the easiest organism to engineer and have been used for research, food production, industrial protein purification, including drugs, agriculture, and art. Going back to our top news, here is our headline for today. Animal news: mice that glow in the dark shed light on cancer research. In the botanical world, scientists created stunning blue orchid using genetics. Under food industry, GMO papaya fight virus-threatening crops. B16, or the cancer glow in mice, a possible step forward for gene therapy of Stanford researchers made mice glow like fireflies. We have Karel and Jansen from the Animal News. Over to you, Karel.
The stunning scientific breakthrough, the surgery helped achieve yet another milestone in the realm of genetic modification. Remember the glow-in-the-dark animals like cats and fish? Well, now mice join the luminescent club. It all started in 2022 when the scientists at Caltech introduced a jellyfish gene for green fluorescence into the single-cell mouse embryo, resulting in the glowing-in-the-dark credence. Fast forward today and we have something even more extraordinary.
Indeed, Karel. This groundbreaking achievement has now birthed a remarkable new technique in the fight against cancer. Meet the glow-in-the-dark mice that might just revolutionize cancer research. This method involves genetically altering mice so that their skin light up as they age or develop tumor. Essentially, their skin practically glows, allowing researchers to monitor cancer progression in real time, from its earliest stage right up to the unfortunate end.
That is it for the animal news.
Back to you, Angelo.
Thank you, Jansen and Karel. Meanwhile, in the other headline, in the Phalaenopsis, the first genetically engineered blue Phalaenopsis orchid, or Phalaenopsis aphrodite orchid, had made its pathway in the genetic engineering. We have Erica and Sophia from the Botanical News. Over to you, Erica.
Make headlines, the botanical world has its own wonder to unveil. Dr. Mashiro Mi and his team at Chiba University in Japan have created something truly magical. The world's first genetically engineered blue Phalaenopsis aphrodite orchid by inserting a gene from the blue Asiatic dayflower into Phalaenopsis cells. They have brought forth a radiant blue orchid, a sight to behold.
Indeed, Erica, genetic engineering is not about aesthetics, it's about resilience too. These engineered orchids not only dazzle with their beauty but also exhibit enhanced fragrance and resilience. Techniques like particle bombardment and agrobacterium-mediated transformation paved the way for these marvels, offering benefits beyond more visual appeal, including potential contribution to conservation efforts.
So that's it for plant news. Back to you, Angelo.
Thank you, Sophia and Erica. Up next, a virus-resistant papaya was genetically engineered to resist infection from a virus called the PPSV or the papaya ring spot virus. For the details of this news, we have Danica and Viernes. Reporting from Food News, over to you, Danica.
From plants that captivate the eyes to ones that nourish the body, genetic modification has left its mark on the food industry. Developed to combat the papaya ring spot virus that threatened the Hawaii's papayas industry in the 90s. These transgenic wonders carry a gene from the virus goat protein, rendering them resistant to its onslaught.
Indeed, Danica. The purpose of GMO papayas is clearly to provide farmers with a resilience crop that can withstand the devastating effect of the papaya ring spot virus, and the benefits are manifold. Not only do GMO papayas boost enhanced nutrition with higher levels of vitamin A and C, but they also reduce the risk of foodborne illnesses and ensure a safer and more plenty food supply for all.
And that is it for food news. Back to you, Angela.
Thank you, Viernes and Danica. As we wrap our segment on GMOs, it's clear that they offer important benefits. For instance, GMOs can help grow more crops with more nutrition and fewer resources like water and pesticides. This can lead to more sustainable food production and help feed more people around the world. While genetic modification has brought incredible advancements, it also comes with risks. Changing the genetic makeup of animals, plants, and food raises ethical questions about playing with nature. There's a worry that modified organisms could escape and disrupt natural ecosystems, and we're not sure of the long-term effects on our health and the environment. Plus, relying too much on genetically modified crops could reduce biodiversity and make us vulnerable to problems like pests or climate change. As we continue to explore genetic engineering, we must carefully weigh the benefits against these potential risks to ensure we're making responsible choices for our future. Thank you for tuning in SSNN, Science Spectrum News Network. I'm Angelo Trinity Pase, wishing you all a great morning.